Today we're going to talk about scatterplots and the relationships in scatterplots. This is a brand new topic, and so I wanted to have a teaching video to go along with your assignments for this week. This is week 5, day 2. A scatterplot is just a graph with points plotted, and we're trying to figure out or see if there is a relationship between two sets of data. You can see right off hand that these points are not in a straight line. This is not a linear relationship with a constant rate of change. That's why it's called a scatter plot, because these points are sort of scattered across the graph. Now, the reason that is because there are a lot of relationships that do not have a linear relationship, that do not have a constant rate of change, but we can still use these graphs to decide if there's association between the two sets of data. Now, these two sets of data are ice cream sales versus temperature. So what we're trying to look at is there a relationship between the temperature outside and how much ice cream is sold? Now, these points over here on the table are just plotted on this graph. We're going to look at how to construct a scatter plot in just a few minutes. It's very hard to tell if there's a possible relationship between the sets of data when you're looking at just the table. So that's the point of the graph, is to see where we can see a better picture of our data. Now, when you look at the graph, you can see that as the temperature increases, as it gets warmer, you can see that ice cream sales go up. They are rising. And that makes sense that when it's warmer outside that there's more ice cream sold. When that happens, when one set of data increasing causes the other set of data to increase, that's called a positive association. It's easy to spot a positive association because the dots of the scatter plot the points will start low and they will increase as the sets of data increases. Now, when we look at associations, relationships, or sometimes they're called correlations, when you see the points rising from left to right, it is a positive association. When the points are decreasing from left to right, it is a negative association. Now, right here in this last one, you can see that these points are just all over the place. They don't seem to increase or decrease, so it just means that the two sets of data do not have any association at all. Relate these back to slope. When we talk about the slope of a line, increasing is positive slope, decreasing is negative slope. So that's a way you can remember what kind of associations and what they look like. Let's look at creating a scatter plot. This data on this first guided practice is the number of points scored by a football team in the first 4 games of a season. And so you can see that our gains are on the x-axis. Our score is on the y-axis. So we're just going to go through and plot this data. Game 1 was 6 points. Game 2 was 21 points. Game 3, 46 points. And Game 4, 34 points. Now, you can see when we look at this graph that this is a scatter plot. It is not a constant rate of change. We're not looking at a linear relationship here, but we can tell something about the data. We can tell something about the association between what game is being played and the points scored. It looks like as the more games this football team played, the more points they scored. This is a positive association. It's a positive association because as the games increased, the points scored increased. So you can see that we're starting low over here to the left, and as we go out to the right, it is increasing. Let's look at another one. This is the number of cookies in a cookie jar from the time since they were baked. Now, when we're looking at this data, we can look at this table and kind of tell what's going on because our data is in order. But let's look and see what it looks like on the graph. The first day after the cookies are baked, there are 24 cookies in the cookie jar. The second day, it falls to 16. The third day, it falls to 10. And the fourth day, there are 7 cookies in the cookie jar. Now, this is not a linear relationship because we can see that it is decreasing by 8, then decreasing by 6, then decreasing by 3. So that's not a constant decrease, a constant rate of change. But we can tell that this is a negative association because as the time since the cookies were baked increases, the number of cookies decreases. So this is a negative association. So let's look at the types of associations. And remember, sometimes they're called correlations. Let's look at the positive and negative associations. Let's look at these positive ones right here. The dots rise to the right. So as you go from left to right, both sets of data are increasing. There is a strong positive association and a weak positive association. Now, the tighter the dots are to each other, the stronger the association. When the dots are more spread out like this, it is a weaker association. Same with negative associations. Here's a strong negative and a weak negative. It's easy to tell when the association is strong. It makes it easier to tell if it's positive or negative. When they are weaker, it is a little bit more difficult to tell if they are positive or negative. Let's look at no association again. The dots are just everywhere. The two sets of data don't have anything in common. Now, from time to time in data, there are something called outliers, and these are just sets of data that do not go with the trend of the rest of the data. This is homework assignments completed versus test scores. So we all know that when we complete more homework, our test scores will go up. So as our homework is completed more, our test scores go up, and we have this pretty strong positive association. When there is one point that lies outside of the data, that means it doesn't go with the rest of the data, doesn't make sense with the rest of the data, doesn't seem to fit the pattern, that's called an outlier. Even though this person completed all 10 of their homeworks, maybe they were sick, maybe they had a bad day, maybe they didn't sleep well, they didn't do well on their test. So there sometimes can be an outlier there. But when we do have an outlier, we are not counting it with the rest of the data. We're looking at the trend of the majority of the data. Now, in this guided practice, I'm going to go ahead and skip to the next page. We're looking at the distance from Canada versus high school completion rate. So the closer it looks like this data, the closer we are to Canada over here, the higher the graduation rate. But as we get farther and farther from the Canadian border, the high school completion rate seems to drop. Now, it's a pretty weak association. You can see how spread out these dots are, but we still can tell if they start high and trend down low. So that would mean that we do have, I'm going to put my pencil there to show you, we do have a negative association. Now, the first question here is what type of association? So we're going to go ahead and mark negative. Describe the strength of the association. So we've already said that these, when we look at the shape of the graph, we can see that it starts high and goes low in a linear fashion, like it continues to decrease. I know this is not a linear relationship, but we don't see any curves anywhere, so we're going to call this linear. Now, if there is an outlier, I am not able to see that because this is such a weak relationship, so I'm going to say no, there is no outlier. Now, when we write a sentence that explains the relationship between the distance a state is from Canada and its high school completion rate, the way we would write that is, as the distance from Canada increases, the high school completion rate decreases. In a negative relationship, you will see that as one set of data increases, the other set of data decreases. Let's look at the next guided practice. This guided practice is hiker's body weight versus backpack weight. Now, when we look at this graph, it asks how many hikers there were, and that's just going to be how many points that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it looks like we have 13 pieces of data. What type of association is shown? So look at the graph and tell me if you can decide, is the pack weight increasing as the body weight increases, or is the pack weight decreasing as the body weight increases? Looks like the pack weight is increasing as the body weight increases, and when they're both increasing, we're talking about a positive relationship. You can see that the data starts low and goes high. Describe the strength. I think this is a pretty strong relationship. The points seem to be in close. And it asks you to describe the shape of the relationship. I think that it is linear. You can see that it is increasing constantly. And is there an outlier? I would say yes, this is an outlier. I would say that little piece of data right there is an outlier. Now, the way we would explain the relationship between the hiker's body weight and the backpack weight is we would say as the body weight increases, the backpack weight increases. They're both increasing, and so that makes a positive relationship. Let's look at this next one. We have student loan debt, years since graduating and remaining debt. Part A asks us, does this scatter plot represent a positive association, negative association, or no association? So take a moment to look at it and decide. I think this relationship is starting up high, and then as the years since graduating increase, the remaining debt is decreasing. So this is a negative association. It asks which person paid off their debt and how long did it take. The person that paid off their debt is the person that has the remaining debt of 0, which if we look over here looks like Brady. And when it asks how long it took, years since graduating, his debt was 0 at 30 years. Now let's look at the next question. Does it appear that the relationship is linear or nonlinear? We've been looking at scatter plots that are continuously decreasing, but I want you to notice a curve that's happening here. This is a non-linear association, because if it was linear, it would continue to decrease in this direction, but it makes a little curve right here. So we're going to say it's non-linear. And which person is an outlier on this data set? So I want you to look at this data and look and see if you can see an outlier. That would be a point that does not associate with the rest of the data. And I think Mike up here is probably our outlier. Now I want you to try to write a sentence with this. I'll start you out. As the years since graduating college increases, what happens to the remaining debt? The remaining debt does what? That's right, it decreases. All right, let's look at this one. This talks about Alex, and Alex wanted to see if there was a relationship between the height of a student and the score he or she received on the math test. So we're looking at this set of data: height, how tall a person is, and their test scores. Does there seem to be a relationship or an association? Can you tell if the data is positive, negative, or is there no association at all? Yes, I think there's no association between height and test scores, and I think that this data proves it, because all these points are all over the place. They don't seem to go up or down. So yes, it has no association. And the reason why we look for associations is so that we can make predictions. What would be an accurate prediction of a test score of a student that is 63 inches tall? And since there is no association, we cannot predict it. All right, this scatter plot has a practice time for debate teams and the number of debates won. I think we all know, without looking at the graph, the more you practice something, the better you get at it. This scatter plot backs that up. So when we look at these points, we see a positive association, because as the practice time increases, the number of debates won increases. See how it is increasing from left to right? So yes, there is a positive association between the hours practice and the debates won. And it asks if this relationship appears to be strong or weak. I would say that all of those points are pretty tight in together, and so that I'm going to choose a strong association. So, which scatter plot best represents a weak negative association? I'm going to give you a minute to think about that. All right, so if I were using my process of elimination, I would say definitely mark out D and B, because those are both positive associations. So we want to concentrate on A and C. Now, both of them are negative, but if it asks which is weak, I would say for sure C is the weak association, because all these dots are kind of scattered out. These dots are close in together. It's easy to tell that there's a negative association there. It's a little bit harder with C. Which scatter plot shows a relationship that is non-linear? I'm going to give you a minute to decide. Now, if I were eliminating things, I would definitely eliminate A. Doesn't seem to be any association at all. I would eliminate B, because it looks like that association is positive, but it looks like it is continuously increasing in a linear fashion. And the same thing with D. But if you look at C, you can see a curve in the data. So I'm going to choose C. All right. That is all for week 5, day 2. You can go to your assignment for Tuesday of week 5 and complete it.